And so again, like I said, this is the last of our webinar series, at least for the spring. So we are recording this, and there's a list of everything we were able to cover this spring. So again, these webinars are designed for MWEE practitioners to think about how they can be using MWEEs in different contexts. And also, like the one Julie's giving today, is focusing on different science topics. So things that just help you, and also think about ways you can use this with students. So all of the recordings live in a Google folder. So that's the link right there. The first time you enter, you will have to ask for permission, but just wait a little bit. We're pretty quick at giving that. And soon, we hope all of these will live on the Chesapeake Bay Program's YouTube playlist. So hopefully they'll be a little easier to share. Before I hand it over, you'll notice throughout Julie's presentation, she gives a lot of great resources. So don't worry about copying those down now. We've actually put together a Google document that's going to live in that Google folder alongside the recording of today. And you'll be able to just go in there and see everything that we've mentioned. So that'll like maybe ease a little stress while we're going through this. So these webinar series are hosted by NOAA Chesapeake Bay Office, which is where I work. Hello, I'm Krista. I also have my coworkers Bart and Elise, and they'll be helping especially in the chat. So throughout the talk, if you have any questions, please throw them into the chat. Julie plans to stop at least once during her talk to answer some questions, but otherwise we'll try to get to everything at the very end. So please know we're not ignoring you. We're making sure to copy all those questions down. So at this point, I'll pass it over to Julie. She also works at NOAA Chesapeake Bay Office. She's the climate specialist. She's also the Climate Resiliency Work Group Coordinator for the Chesapeake Bay Program. So she has a lot to share with us about what's happening in our region.
Thanks, Krista. Yeah, I'm excited to be here, and thank you everyone for tuning in virtually. And so first, before I jump into the presentation, I just want to tell you a little bit about myself. As Krista mentioned, I'm a natural resources specialist with NOAA's Chesapeake Bay Office, and I'm also the Climate Resiliency Coordinator with the Chesapeake Bay Program. And now the Chesapeake Program, I'm going to talk a little bit more about this partnership effort. NOAA is part of the partnership to help restore the Chesapeake Bay. So a little bit more about my background. I have a bachelor's degree in biological sciences. I also have a master's degree in environmental sciences. And something neat about sort of my career choices and the career pathway that I ended up choosing was very much shaped by educational experiences. So I have a great appreciation for everyone who offers opportunities to high school students, to college students to get real world experience. And that really shaped my direction in my career. I had a fellowship with NOAA that dealt with fisheries management and studying habitats and ecosystems and impacts to fisheries. And then I had a fellowship opportunity with EPA at their headquarters office in Washington, D.C., where I learned how to apply science in making policy decisions and different regulatory decisions. So those educational opportunities and the great mentors I had really shaped the direction I went with my career path. So for today's presentation, I'm going to talk about the Chesapeake Bay Program Partnership and the Watershed Agreement as it relates to climate resiliency. I'm also going to talk about some climate change impacts on Chesapeake Bay's natural resources and our communities. And I want to end the presentation in sort of talking about different climate change trends and how we're using that information to inform resilience strategies and decision-making in the Chesapeake Bay watershed. So the Chesapeake Bay is a pretty large watershed. It's around 64,000 square miles, and it incorporates several states. And these states we refer to as jurisdictions that help us with our restoration efforts. We have New York, Pennsylvania, Maryland, West Virginia, Virginia, Delaware, the District of Columbia, and all these groups are part of this watershed. Now, the Chesapeake Bay is rich in its history and natural beauty. It is considered a national treasure, and it has a lot of diversity with different species, from anywhere from birds to fish to benthic organisms like crab and oysters, and it encompasses a lot of area too with the shoreline. So we have a lot of coastal communities that live along Chesapeake Bay as well. Now, the Chesapeake Bay, again, it's in a sense as an identity for the people that live in this area. It has a lot of recreational, commercial, and cultural value. We have everywhere from fly fishing to hunting to water recreation, boating, sailing. We also have a waterman community with fishing, and the bay produces about 500 million pounds of seafood per year. And we have many different species of birds as well. So it's gonna be great for bird watching. And then those who are into duck hunting, there's options for that as well. And there's a lot of enjoyment with the Chesapeake Bay. However, we are dealing with some pollution troubles, even with the current climate conditions and the way we use our land. And this has been ongoing for quite some time, and the main source of our bay pollution problems come from excess nutrients entering the watershed and also excess sediments. And this happens from different storm events. We have runoff from fertilizer from farms, and we end up getting into a situation where the habitat, the aquatic habitats end up being quite poor, and they don't have the right level of dissolved oxygen. So we get a lot of algae that grows, and then that deprives the system of oxygen, and then we have a habitat that can't support fish. So we'll see a dead zone that will form. We also have, because of the runoff, there's some bacteria issues, so there are areas that are not safe for human health as well. And these problems were identified back in 2008 through a regulatory program through the Clean Water Act. So the states are required every 2 years to assess their waters, the health of their waters. They have standards that they look at. And if it's not meeting those standards, they have to develop a pollutant cleanup plan. And that is known as a total maximum daily load, to figure out how much we need to reduce in the amount of nutrients and suspended sediment that's loading into the bay, restore the water quality, and then restore the habitat. Now, as I mentioned, the Chesapeake Bay watershed, it encompasses many jurisdictions, many states and local areas. And so in order to tackle this pollution problem, we decided to use a partnership effort. And I'm always impressed by this partnership because it encompasses a lot of state agencies, local agencies, academic institutions, non-governmental organizations, and federal agencies. And essentially, we all have come together, and we are using the Chesapeake Watershed Agreement to guide our restoration efforts for the Chesapeake Bay. And the Chesapeake Watershed Agreement, they have some large goals, and the key goals that we're trying to achieve are centered around sustainable fisheries, vital habitats, clean water, conserve lands, so those culturally valued lands, engage communities, so citizen stewardship, and climate resiliency. Now, I'm the Climate Resiliency Coordinator with the Chesapeake Bay Program Partnership. There's many different work groups within the Chesapeake Bay, and we're all tasked with trying to meet the goals and outcomes under the Chesapeake Watershed Agreement. Now, the climate resiliency goal involves increasing the resiliency of the Chesapeake Bay and watershed, including its living resources, habitats, public infrastructure, and communities to withstand adverse impacts from changing environmental and climate conditions. So I showed a couple of pictures here. These are some of the issues that we're dealing with in Chesapeake Bay, is that we're experiencing more intense storm events, which means that there's more volume of water that is falling in a given time, and we're seeing those type of storms more frequently. And that can lead like problems like we see in the Anacostia River. This is with a intense storm event back in July 2017 that caused a lot of debris and suspended sediment to enter the watershed. We also see sunny day flooding, And this occurs because of sea level rise that's occurring in our area, which I'm going to talk a little bit more about in some further slides. But Annapolis back in October 2019, and this actually happened just recently as well, this year, they're seeing more events where it could be a sunny day and then we get flooding, and that's because of the tides, the high tide coming in due to sort of the sea level rise issues that we're dealing with in these lower lying areas. So we have a commitment with the Chesapeake Bay Program partners in achieving our climate resiliency goal, and we have two major outcomes that we're focusing on. And one is monitor and assess trends and likely impacts of changing climate and sea level conditions on the Chesapeake Bay ecosystem. So we need to collect information to know what direction are we going in addressing climate change and meeting our water quality goals and our restoration goals. We also pursue, design and construct restoration and protection projects to enhance resiliency of the Chesapeake Bay. And we want to enhance resiliency to sort of several issues that are occurring because of climate change. And that has to do with coastal erosion, coastal flooding, sea level rise, and these more frequent intense storms. All of these issues actually could make it more difficult to meet our restoration goals through the Chesapeake Bay Watershed Agreement. So I just want to talk a little bit about how we look at climate change and sort of the projections we use to help inform decisions and trying to understand what strategies we need to be put in place. So there's a lot of work that's done to try to project what the greenhouse gas concentrations are going to look in the future. And a lot of this work comes out of the Intergovernmental Panel on Climate Change, and they have a fifth assessment report. I included the link here. The website's actually quite well done. You can click in different areas to learn about different issues. There's a lot of information there, though. It's a pretty large report. And they developed these representative concentration pathways. So you can view these as scenarios. And we have different scenarios of what the greenhouse gas concentrations could look like in the future. And a lot of times in decision making, we look at sort of more of a near term, like a 2025, to then we look at like a mid-century, like 2050, and then end of century around like 2080 to 2100. And you'll see here with this graph, these are the sort of the main scenarios we're looking at. We have this highest emissions pathway, and that essentially is saying that we're not going to do much to reduce the amount of greenhouse gases that's being released. And so we're going to continue using coal burning facilities. We're not going to do much with renewable energy. And so you'll see that that is the worst case scenario. Now, with the efforts that's going on currently in the world, we're probably more in this pathway for the RCP 6.0 and the pathway 4.5. We're kind of teetering along these two pathways where there are efforts being put in place to reduce the greenhouse gas emissions by using renewable energy sources, by looking at ways to reduce emissions from vehicles. And so just sort of those strategies that are being put in place. And then the best case scenario, where is the goal of the Paris Climate Agreement, is this lowest emissions pathway. And that's where we would like to be. That's what we're aiming for. We're not quite there, but that's the goal. And that would create the least amount of impacts. And we would have to do less from an adaptation standpoint if we could accomplish this goal. But because we do still have increasing greenhouse gas concentrations, and we do have sort of these more higher emission scenarios occurring now, while we still have to do efforts to mitigate our emissions, we are also going to have to think about adaptation, because climate change is occurring now. I'm going to go over some trends that we are seeing. And so we're going to have to also adapt, because things are shifting, things are changing a bit. But our goal is to figure out adaptive strategies that will make us more resilient against those changes, so we're not having detrimental impacts to our society or to our ecosystems. Now, the different impacts that can occur with these increased greenhouse gas concentrations, that we're going to see a higher average Earth temperature. And we're also going to see precipitation changes, more extreme storm events in some areas, and then there's also drought issues in other areas. And then we also have sea level rise with the glaciers melting, the polar caps, and also with thermal expansion. We're going to see land lost as the seas rise. And then we also have ocean acidification. So there's a shift in chemistry happening because the excess carbon dioxide in the atmosphere gets absorbed into the ocean, which shifts the chemistry, and this can also affect habitat for aquatic organisms. So in order to make decisions, we need to downscale climate modeling data. So those scenarios I showed you, they're global models, and they give a lot of great insight on what the trends may look like from a global scale. But to make local decisions, we actually need to take those models and downscale them to a finer spatial resolution. And then that way we can actually couple the climate models with hydrological models and land use models to help make decisions in our watershed of how we can adapt or how we can build resilience to these changing climate conditions. Now, there's different methods of downscaling models, and this in itself is a career. There are people who will spend their entire career trying to develop and modify and refine these downscaling approaches. But the two main approaches deal with dynamical downscaling, which is process-based, which is using principles of physics and have what we know of the natural world and plugging data into that information. And then we also have statistical downscaling approaches. And this uses observed empirical relationships with data that's good. Now, there's pros and cons to each approach, but for decision making, we don't view approaches right or wrong. We view sort of the from these models as different scenarios and a range of future possibilities that we have to plan for. And so from a decision-making standpoint, we use usually more than one of these models. We kind of compare them and look at them, and we look at that range of possibilities, and then we make decisions around it. I included a link here. This is quite a complex topic. I could do a whole presentation on climate model downscaling, but if you were interested, this was a pretty good document that you can take a look, and they kind of compare the different methods. So now in Chesapeake Bay, we've been using these downscaling approaches, and we are trying to come up with projections of what is it going to look like in 2025, 2050, and 2080. I'm showing 2025 here because that's what we're focused on right now. We're trying to put practices in place to meet the goals in the Chesapeake Watershed Agreement. And so we're looking at what sort of changes we're going to have to consider in 2025. So for sea level rise, we're seeing that there's probably going to be around a 1/2 foot rise in 2025. And for temperature, we're going to see increases from around 2 degrees Fahrenheit. And for precipitation change, we're seeing on average a 3.1% increase. So here in Chesapeake Bay, we're going to be warmer and wetter. And some people will even say we're going to be wilder with the extreme storm events that we're going to have to deal with. So now, using these projections, we want to assess trends to help inform our decision making. And trends kind of incorporate different time scales. And so we need to know information about the past. So we have data from past observations to kind of establish what our baseline conditions are. We know what works and what doesn't work from a standpoint from baseline, from the practices we're putting in place, if it's stormwater management, if everything stayed the same from how we design those stormwater management practices, then we would have some confidence in saying what worked and what didn't work. So past observations kind of set that baseline condition. We also have where we look at present trends. So this is change from those baseline conditions. And we look to see, are we on track to meet the desired outcomes? And in cases we may not be, and we have to adapt and adjust. And the one difficulty though with climate change is that it sort of changes the baseline on us. And so we need to understand what future climate and what the impacts would look like to make decisions around it. So future projections help us look to see if our present trends are on the right track to meet these future projections that we're seeing. And so we ask questions like, will restoration efforts achieve desired outcomes under these changing climate and sea level conditions? And then if not, then we work towards identifying and implementing resilience actions to increase the likelihood of meeting the desired outcomes. So this is sort of a very much adaptive management process. So with climate change in Chesapeake Bay, we're very much interested in understanding more about the ecological and community impacts. As I mentioned, we're already dealing with water quality problems from runoff and from either from agricultural runoff, from fertilizer entering the watershed, or urban runoff, stormwater. And we have also just with temperature, increasing temperatures, more chance for algae to grow and deprive the system of oxygen. But even currently now, the Chesapeake Bay deals with a dead zone and has low oxygen and poor habitat for those aquatic organisms. And so now with changing climate, it adds another layer of complexity and another layer of consideration, because we're going to see increasing frequency and intensity of precipitation, which can lead to even more runoff. And then we also see these increasing sea surface temperatures, which is going to create an environment where algae can flourish more and deprive the system of oxygen and more widespread. And so now we have to sort of think about how are we going to deal with these ecological and community impacts, and look at the trends and then try to inform what resilience actions we can take. And there's many different impacts that we're focused on right now with the Climate Resiliency Work Group. We're looking at flooding and infrastructure damage from sea level rise and from these extreme storm events, land loss or changes in land use. Again, we're good with sea level rise. And we're also looking at increased threats to human health and safety with this urban heat island effect and extreme storms, degraded water quality and habitats with excess nutrients and low dissolved oxygen, and ecosystem and seasonal shifts. How is that going to affect the fish and the tree species, distribution and diversity? And then is there going to be increased vulnerability to invasive species or disease? So I want to go over some trends that we're seeing now in Chesapeake Bay. So Chesapeake Bay, when it comes to sea level rise, is a highly vulnerable region. You know, actually, I think I'm going to pause here because I think I was supposed to pause for questions, Krista, after this slide. So maybe we'll pause here before I jump into the present and future projections for each of these issues.
Yeah, so we do have 2 questions, and before I get into those, if you are on your phone, just a reminder to hit *6 to mute yourself because we're hearing a little bit of feedback. But our first question came from Meredith, and she asked, what metrics should NGOs and other funders be tracking to help monitor the efforts towards climate resiliency? They traditionally track MPS reductions, but what else can they look at?
Yeah. So I'll go more into this later on the presentation as well. But one thing that we also need help is like tracking sort of resilience actions. So if there are efforts to build, do forest buffering along a stream, that's a resilience action that can help lower the temperatures of the water. And so we're trying to put that information together and tracking, but we also need, when it comes to like assessing trends with climate change, we need more long-term data sets as well. And so sometimes we run across an issue like with stream temperature. So we have stream temperature data, but at the same time, it may be not always consistent in one spot. So we need sort of those sentinel sites, those sites that are areas that where confident that we'll have some continuous monitoring that we can then assess trends over time. Because with climate change, we are looking into, like, it's a large time frame, it's a 2050, 2080. So the more data we can get from specific locations of interest, like if there was certain streams that had critical finch habitat, if we had a program in place that would be like a site that would have more continuous monitoring occurring, and we don't have gaps in our data set. So it's sort of like trying to create a monitoring plan that can provide some consistent data over a longer period of time.
So I'll just leave you with one more question. It was from Hema, and I guess when you start to get more into the Chesapeake region, she was wondering if you guys also look into diseases related to climate change.
Just for a clarification, are we talking about human diseases, tree diseases?
Hema, if you want to chime in there.
Yeah.
Yeah. I guess there's a few different things you could think of.
More related to human disease.
Yeah. As a Chesapeake program, we're not currently looking at that, but I know that there are some international efforts and national efforts that is looking into how these changing climate conditions will affect virus spread or disease. And so a lot of those efforts are coming like out of the Department of Defense or Homeland Security. They have some groups that do that. The Chesapeake program, we're more focused on sort of the natural ecosystems. From a human component, we look at public safety, so with flooding issues, and also like heat island effect. So we have this sort of danger that people can, they don't have proper cover or air conditioning, that they can get dehydrated and ill and heat stroke. So we look at those kinds of things, but when it comes to sort of that, the viruses and the disease spread, we don't necessarily have that expertise within the Chesapeake Bay program, and that's more, I think, of a national effort and international effort with other agencies.
All right, we can touch on the other questions at the end if you want to keep going, Julie.
Okay, yep. All right, so I'm going to talk about now, as I mentioned, some specific trends. So one thing we focus at the Chesapeake program is sea level rise. Now, the Chesapeake Bay is a highly vulnerable region to sea level rise. There's a few things happening. It's rising at a faster rate because the land under is also sinking. And so we have sort of this, this double whammy of an issue where land is sinking and sea level is rising. And so there is a lot of risk to our coastal communities with flooding and land use. There's also risk to our natural habitats with wetlands and marshes that our diverse species in the Chesapeake Bay with birds and fish rely on. And so we are definitely much focused on figuring out, well, how do we build resilience around this issue and how do we adapt to it if needed? And so with the present day conditions, we have seen sea levels rise around 1/2 to 1 foot. And for future projections, we're seeing that sea levels can rise anywhere from 1.3 to 5.1 feet over the next century. And here I'm going to do a demo of Chesapeake Progress a little bit later on. We do track some of some different stations for sea level rise. These are tide gauge stations. And so these are, like, as I mentioned, sort of those sentinel sites that has consistent data that's monitored through time that we can use to sort of assess the trend, the climate change trends. So I'm going to show you a tool that was developed by NOAA, the Office of Coastal Management, and this is a sea level rise viewer. And it's a very useful tool to kind of give yourself a visual of what is going to happen to the area with land loss with sea level rise. So I'm going to try to pull this up. Hopefully it will work. All right, good. So we're going to zoom in. So it's actually, you can look nationally at the trends, sea level rise trends. We're going to zoom in here to Chesapeake Bay, and hopefully everyone can see that all right. And so here we'll zoom in. This is the Blackwater National Wildlife Refuge. This is very important habitat for different bird species and different fish. Now, right now it's set to local or to current conditions. And so if we were thinking back to those projections, we're seeing around by 2025 was going to be around half a foot, which they only go up to 1 foot. So we'll go up to 1 foot. And you can see that is quite a change that's going to occur. We're pretty much going to lose the Blackwater National Wildlife Refuge. It's going to be underwater. If we go back to current conditions and then 1 foot. So that's how extensive sea level rise can affect our land, our shores, and our coast here in the Chesapeake Bay area. And this is also an issue if we zoom into, see if we can find. Let's look for it. There's Annapolis. You'll see Annapolis, they do deal with tidal flooding. Now, if we look at projections up to 3 feet, you can see there will be a little bit more flooding. So each area of the Chesapeake Bay will be a little affected differently. But a lot of the islands in Chesapeake Bay, they are going to essentially be lost. And we have to come up with strategies and plans, especially if there are populations living on those islands, of how we're going to address sea level rise. So this is a really great tool, like it's a great visual. There's other information in here as well to look at sort of the high tide flooding and marsh migration. So I encourage folks to play around with it, and it could potentially be useful too to help with visuals if you're doing like a sea level rise exercise with your students. So it's, yeah, there's a lot of information here. Let's see. So we deal with flooding from sea level rise, but also there's precipitation is an issue as well. As I mentioned, Chesapeake Bay is going to be much wetter. We are seeing a change in total annual precipitation in the Chesapeake Bay watershed. For more of the upper part of this watershed in the New York area, they're seeing increases of anywhere from 10 to 16%. And this is current increases from a baseline. And the baseline that we're looking at here is from 1901 to 2000. So it's kind of what when we look at trends in climate change, we always sort of pick a baseline and then we say, well, anomalies that are above certain events that we would typically have seen, how more frequently will that occur? And so with precipitation, there are different areas that's experiencing, in this case, much more rain and an increase in total precipitation. But there are also areas in Chesapeake Bay that is experiencing less. And so I kind of want to just point this out because when we're trying to make local decisions on how to be resilient to these changing climate conditions, it's not a one size fits all. So we have to really kind of look at these different regions and figure out what would be the best strategies for what is being projected for that area and also what they're experiencing currently. And so really with Chesapeake Bay, for the most part, it has been wetter, receiving 0.2 to 0.7 more inches of rain. Future projections, they're projecting on average, the area would have an additional 5 inches per year. I want to provide a local example. This was a really well done report by the University of Maryland, and this was part of a requirement by the Maryland Commission on Climate Change Act of 2015. They asked for a sea level rise expert panel to kind of look at projections and see how it would affect the state of Maryland. So this example is in Baltimore. And so they're looking at tidal flooding in Baltimore based on projected sea level rise impacts. So kind of to orient you to this graph, this is showing us flood days per year. So when we would see flooding into the city, where you can see the pictures there, and this is like over a period of time. So we have current conditions before 2020, but then we have projections that are used to look at beyond 2020. And you'll see there's a different scenarios I talked about. So we had the low emission scenario with the Paris Agreement, stabilized emissions, growing emissions. So the growing emissions is our worst case scenario. We're probably more going to fall along the line of the stabilized emissions scenario. And if you look at this, the blue bars show the best case scenario. So even with the best case scenario, we're still, with sea level rise, going to see quite a few flood days per year, around 280 at the end of the century. And that can raise up to 300 to 365, depending on these emission scenarios. And if you look at more short term, they typically see 10 days flood days per year. And by 2040, they're projecting it's going to be around 30 flood days. So this has a lot of implications. We're going to have to manage around this, and we're going to have to figure out strategies to deal with flooding into our cities. And so groups like this, this type of information is helpful to start informing decision making, to understand, okay, the extent of the problem, figure out what the range of future possibilities are, and then make decisions around that. So here's some air temperature trends. Overall, Chesapeake Bay is increasing in how warm the average air temperature increases are. And this is ranging from 0.4 to more than 2.5 degrees Fahrenheit. Future projections, we're looking at 4.5 to 10 degrees Fahrenheit by 2080s. And so those darker areas show areas that are exhibiting higher increases in average air temperature. And with the average air temperature, it also results in increasing our water temperatures, which can cause the water quality problems I discussed earlier. And that's one thing the Chesapeake program we're really focused on, is try to understand, well, what exactly is happening with water quality under changing climate conditions. Are the measures we're putting in place now, will it be good enough for the future? So these are an example of an ecological impact. These are analyses that are being done by the Chesapeake Program's office, their modeling team. And they're looking at different factors of climate change. So they're looking for sea level rise, watershed flow, so that's from the precipitation, higher precipitation events can adjust watershed flow, and increased temperatures. And it was really interesting sort of what their analysis showing with bottom dissolved oxygen. So this is a criteria that's very important to monitor, and is one of the parameters we're trying to improve in Chesapeake Bay, because dissolved oxygen is very important to the bay, to the aquatic resources that we rely on. And so with sea level rise, they actually saw, if this is, you look at the blue color, they actually saw a improvement in bottom dissolved oxygen. Same with watershed flow. In some areas, a slight improvement in these bottom waters. But that was all overshadowed or overwhelmed by increasing temperatures. So when you look at all factors together, because of the increasing temperatures, we have very little areas that's going to be positively influenced by climate change. Most areas are going to be negatively influenced by climate change. And they're finding that with our current measures, we're going to see the majority of the segments that we're trying to restore in the Chesapeake Bay to not be meeting water quality standards for dissolved oxygen. And so this is where now we have to make some decisions to figure out, well, what other practices can we put in place that will help with this temperature issue. So I'm going to pull this up real quick and do a time check quick. Okay. I want to show you Chesapeake Progress, because there's interactive maps here that may be of use if you're putting activities together to talk about climate change. And we're still building on this site. It's a work in progress, but we do have some climate change indicators on here that I showed with average air temperature. We also have change in high temperature extremes. We have also stream temperature change in total annual precipitation. And there's also some flood related indicators with river flood frequency, river flood magnitude, and then relative sea level rise. We actually don't have a lot of information here. The NOAA sea level rise tool is probably your best bet to look at that. But we're hoping to build on this in the future. But what's neat about this, you can actually go and you can type in any this is Chesapeake Bay specific. You can type it in and you can see kind of what region we're falling under. So this Annapolis area, we're looking at a 4.59% precipitation change, an increase. And so you can kind of start exploring the data. And with all of these, you can actually pull up the data. If you are maybe at a high school level class, you want to have them kind of explore data with Excel or and look at this, you can pull that up. There's also methods. So we have pretty well described methods of how this data was generated, what was the source of data, what can be used for, and how to interpret it. So I encourage folks to check this out, and I'll be having my contact information at the end. If you have ideas of how this information could be more useful to you from an education standpoint, I very much would like to hear those as well, because we want to start building on this and eventually link this with the impacts I was talking about, and also link it with different climate resilience actions. So more of a narrative of how we can use this information to inform decision making. So that is a current project we're working on. It's probably going to be a little bit around 2 to 3 years before we get it shaped up exactly how we want. But just sort of right now, this is available that people can explore and use. All right, so I think this is another opportunity to pause for questions.
Yeah, so to start off with maybe a quick question is, Dave asked, when you were talking about the 2025 projected changes, what was it in relation to? Like to the 2000 levels or something else?
Oh, yes. The baseline, let me go back to that one. So they're using the representative concentrated pathway 4.5. So that's where there's more efforts being made to reduce the greenhouse gas emissions. But they're comparing it to, and I actually did not make a note of this, but I believe the baseline is like 1990 to like 2007. But I can definitely send you that information. There is documentation for this that the modeling team, what they've been working on. But yeah, they do have a baseline that they're comparing this to. And then they're using, for temperature, for instance, they're using the projections from this representative concentration pathway 4.5, but they're using other downscaling approaches for like sea level rise and precipitation change. So if folks are really interested in sort of the methods of that, I can get in touch with the modeling team and try to be able to maybe put some documentation in that folder.
Yeah, we can add that to the document. So another thing to potentially add to the document is when you were doing those maps you just passed about dissolved oxygen, I don't know if those maps are included in a resource we already attached the document, or if maybe that's another source.
Yeah, so this is a relatively new analysis that the modeling team what they have done. I'll have to check with them to see. They presented on it during one of their modeling work group meetings back in, I think, February timeframe. And so I'm not sure where the documentation is for it, but I can definitely give the contact information if people are interested in learning more about this.
Okay. And then just one more clarification question. When you were on the sea level rise viewer and talking about Blackwater, this might just be because of where Blackwater is, like how high it is. But you talked about other areas being affected differently, and is that really just in relation to their level above sea level?
Yeah, so it's
Yeah.
based on elevation data.
Okay.
So yeah, so that's why different areas will be affected differently, because it's not consistent elevation throughout the whole Chesapeake Bay.
All right, thank you.
That area is particularly a low-lying area with the Blackwater Refuge. All right. Okay, so just sort of to wrap up the presentation, I just want to kind of show you what our next steps are with the Climate Resiliency Work Group and trying to use this information to develop indicators to track climate resilience. And currently, as you can see, we've made some progress with these physical indicators, which is pretty much looking at trends that deal with sea level rise, change in precipitation, and change in air. And we're working on right now water temperature. But it will be important to connect these to the impacts in order to come up with strategies to be more resilient to these physical changes that's occurring in our watershed. So we've been brainstorming with some other work groups within the Chesapeake Bay Program partnership. There's many work groups who focus on all the different goals we're trying to achieve in the watershed agreement. And we've been talking with the fisheries team, and we are going to try to take this information and connect it to fish habitat and looking at water quality suitability for key fish species such as brook trout, forage fish, and striped bass. And also we're working with the wetland work group to see how the physical changes are affecting wetlands and marshes. Essentially, we're going to get in a situation that because of sea level rise, we're going to have marsh loss potentially. So there are strategies that can be put in place to allow marshes to migrate if you have corridors for them to migrate. So those are a lot of with land use planning to deal with sort of this habitat loss issue. And then also looking at sort of changes in fish species abundance and distribution, where because of the increases in temperature and the increases in water temperature, we could actually exceed certain thresholds that are important to certain species of fish, like striped bass. We may not see striped bass migrating into the Chesapeake Bay area in a future climate scenario. So we're looking into sort of these impacts. Eventually, where we want to get is to build climate resilience indicators to track how prepared we are for these changes and these impacts. And we've been discussing indicators around conservation and preservation. So we are doing different analyses to see where different critical habitat areas are. Are there any areas that happen to be in climate resilient locations? And why are those areas resilient? For example, we can find that maybe within the watershed, there's certain brook trout habitat that projections are showing that maybe with a 6-degree change that they're not being as affected. And we're finding that, well, there's less impervious surface in that area. Essentially, there's more trees. And so it's more of a cooling effect. So that brings us to like, well, are there best management practices we can put in place to lower the temperatures in priority fish habitat areas? And also looking at sort of also living shoreline, building like wetlands, wetland restoration, implementing those strategies to build habitat. And also with wetland restoration, with these living shorelines, they could also help with sort of storm surges and reduce wave energy and maybe assist with some of the flooding issues in our coastal communities. We also looking at like what we were calling behavior change. There is going to be given the projections and what we're facing, we're going to have to adapt. And so can we start building into our plans, for instance, like in our land use plans, allow for wetland and marsh migration in land use planning? So these are sorts of things we're thinking about. We are in the very early stages of connecting all this information, but the goal is to actually have a climate resilience scorecard for Chesapeake Bay watershed communities that make these connections. But we have a lot of pieces here that will help lead to this. And a lot of it is that we we need to do more research and we need to gather more data, get more information. And actually two areas that the Chesapeake Bay Program, the Climate Resilience Work Group, are focusing on is BMP climate resilience assessment efforts. So we have a lot of best management practices that we currently use to restore the Chesapeake Bay and try to reduce excess nutrients. We really don't know how they're going to perform under changing climate conditions. So we're trying to find ways to support research to answer those questions. And we also have the climate indicator development. So we have where we're trying to put those physical indicators in a format that could help inform the impacts, and then which would then lead to informing what our climate resilience actions could look like. And that could be forest buffers. They are looking to be a potential strategy in reducing stream water temperatures, and then the living shorelines, as I mentioned, to reduce wave energy and build habitat. So trying to see what these best climate resilience actions be for the given areas. And all of that is to try to meet the goals and outcomes in the Chesapeake Watershed Agreement to have a healthy Chesapeake Bay, sustainable fisheries, and clean water, and so that we can still enjoy the Chesapeake Bay and we can still benefit from the ecosystem services that it provides to our communities. I just want to point out a couple of climate resilience resources. There's the U.S. Climate Resilience Toolkit. NOAA has helped develop this. This is a very much a partnership effort across many different organizations, but it's a very neat resource because they are trying to compile case studies of different climate resilience projects. And there's a few for Chesapeake Bay, but this is national, so you can give people ideas of what sort of practices that people are experimenting with or testing to build resilience to changing climate conditions. Also has information on experts that you could get in touch with. And so it's a great resource. And eventually what we would like to do with the Chesapeake Bay Program is build in sort of our efforts into this as well. I also want to point out the Chesapeake Watershed Forum. Their theme this year is climate resiliency in the changing Chesapeake watershed. So if you're very much interested in the information presented today, this is going to be very much a focused conference on these sorts of issues from what different organizations, what they're doing to address climate change and what they're doing to build resilience. So that's on October 30th to November 1st. They're still trying to decide whether to shift it to a remote virtual conference experience. So those decisions they're looking to make later in the summer. So concluding thoughts, climate change is already affecting the Chesapeake Bay and its watershed, and overall it's going to be warmer and wetter. And to increase the likelihood of meeting our restoration goals, information is needed on past, present, and future projection conditions related to changing climate and sea level rise. And it is important to connect these physical changes with impacts to ecosystems and communities to better identify and implement climate change resilience actions. I'm going to turn over to Crystal. She has some additional resources that she would like to share with the group.
Yeah, thanks, Julie. So yeah, as a reminder, we'll have a Google Doc in the Google Archive folder along with the recording of this webinar with everything Julie talked about, some of the other things that came up in the chat, and then thinking about this in the MWEE context, if you're doing a climate change related MWEE, of course, you also want to be thinking about action students can take. So we just want to bring everyone's attention to Project Drawdown. It's a really great resource. It can start you off with a great list for students to choose from. And thinking about our different contexts right now with everything that's going on, there's a lot of actions on there that can be accomplished at a student's home or in a community. So it's a way they can start exploring some of these actions. So if you want to do next slide. So just another reminder of where all these webinars live. It's on this Google folder. And again, soon we hope they'll all be living on the Chesapeake Bay Program's YouTube page. And just to think about the summer coming up, we are working with some of our partners to put together a Mid-Atlantic Climate Change Education Conference at the end of June. It is virtual, and we've already sold out once, so we added a few more seats. So if you're interested, go to that website that's listed there and sign up. At the end of July, there's a Stay In Institute. It's a 3-day online course with climate generation. And so I know they're incorporating online work, but also having you get outside and doing some exploration on your own. So you can go to climategen.org, look at their courses, and find out about that. And then one last thing, for our MWEE practitioners out there, we have a MWEE 101 course, which I know many of you are very familiar with, on Chesapeake exploration. And just today, we opened up a brand new course called MWEE 201. So it's building off of 101, and just like 101, it's free and it's self-paced, and we hope you guys will think about it for the summer. You can contact me if you want to become a non-editing teacher on the course, and you can use it with your participants. So I'll throw a link in the chat for that. So I think the last slide, Julie, is just the contact information. So we do have a few questions that came up. The first one was, what are some of the big solution-oriented careers that you see on the horizon for folks in the Chesapeake region that are like climate-related careers?
Well, there's a lot of, like, from the mitigation standpoint, I see a lot of like engineering towards renewable energy and those sorts of solutions. We do need that. We need more people who are coming up with solutions to mitigate the amount of greenhouse gases and emissions and the concentrations, because we can try to do all we can to build resilience and adapt, but eventually the adaptation strategy will be that we just have to accept this is a change, and we're not going to have certain species in Chesapeake Bay, or we're not going to have certain areas, we're going to have less land. Coastal area is going to strategy we have to figure out, shifting people more inland. So it is crucial that we have sort of engineers looking at these sort of renewable energy sources. But then this sort of talking about resilience though, because even though if you saw in some of the information I presented, even if we reach that goal with the Paris Climate Agreement, with our in reducing the amount of emissions, there's a delay effect. Like there's the greenhouse gas concentrations in the atmosphere. It just like won't be an instant fix. If we tomorrow we 100% went to renewable energy, we had no emissions, and we would still see an increase and eventually would level off. So we are, as I've shown, we are seeing climate change impacts now. So I think another area is having more experts in evaluating climate change impacts and then building resilience strategies. And so sort of looking at risk assessment, but then looking at strategies to build resilience. And at least with NOAA and the Chesapeake program, we're very much interested in green infrastructure projects. How do we restore wetlands? We may have to do things differently than how we've been doing. Like, how can we restore wetlands in a way, with spatial considerations that would build resilience? Having it, for instance, if you do it all patchy and there's no strategy, it may not build resilience to these changing climate conditions, but maybe grouping certain restoration projects together would. So sort of having people that will help build sort of these resilience strategies moving forward and doing these analyses, that would be very helpful moving forward in the future.
So it is 3 o'clock, but we have more questions if you don't mind hanging around, Julie.
Yeah, I'm fine. Yep.
All right, so Tom asked, when you're talking about dissolved oxygen, he's curious as to why increased sea level rise and watershed flow might result in improvements in bottom dissolved oxygen. Is it due to like increased mixing?
Back up. Yeah, it was a very interesting finding that the Mullen team found, and it had to do with, so this is deep water, and with sea level rise, you're going to get more of sort of a larger volume of area. because of that larger volume of area and the gravitational circulation, it actually, you have it where it was less of a concentrated area. So you have more volume of water that it impact the dissolved oxygen less. So there's actually caused an improvement. Watershed flow, I think that had to do also with just more water entering the system. And so you had where you had this more volume of water. It was a very interesting finding. And it has some issues like dealing with depth and from what our current conditions are. And yeah, so I'll see if they have documentation on it. They may have not developed the report yet, but it was an interesting finding when they were looking at it. But with that said, the increases in temperature pretty much wiped out any kind of benefit that we were observing from that. But I would be curious, and this is me putting my resilience hat on, if you looked at this all factors graph, if there are areas of critical fish habitat that happens to coincide in areas that benefited from sea level rise or watershed flow, that if we preserve and conserve those areas, put policies in place, that maybe that is a better resilient action than focusing on habitats that are too far gone. So those are sort of the questions in my position that I'm thinking about, is like, well, is there some more advantageous areas to target, because there maybe there's some other things happening that could build resilience in that particular habitat.
And then with all these educators, I did see one question come in about, are you aware of any like citizen science projects that students could get involved with, like around climate data?
We do have a citizen stewardship work group at the Chesapeake Bay Program, and I'm pretty sure that there are some projects that people are working on. I've heard about like with urban tree canopy, like planting trees. So that may be something we can work on, compiling some of those projects and information, because that would probably be of interest, especially to this group, of maybe where they can get involved. I know there are different nonprofits that do work on this, and it could be anywhere from where they're trying to plant trees in an urban setting to address the heat island effect. There's groups that help with stream restoration and tree buffering. Though some of these practices, they benefit just from a water quality standpoint with excess nutrients that we're experiencing now, but they could also coincide with building resilience to these changing climate conditions. So they may not advertise, I guess, as like a climate program, but sort of the activities they're doing could build resilience to climate. Maybe so that's maybe something we could work on to compile sort of those resources for folks to look at.
So maybe I'll include a link to that work group you mentioned in the folder. And then I saw other people were writing in like Field Scope and Globe, Watershed Stewards. So there's definitely things out there.
Yep.
So thanks for sharing all of that. So at this point, if people want to jump on, they can turn on their mic and ask questions. I'm not quite sure who might still be in there that asked some of these questions further back.
Hi, this is Dave Armchuk. I had a question.
Yeah.
You mentioned earlier on extreme weather events as a result of climate change. Are people in your office or folks studying the Chesapeake Bay region looking into that? And what kind of information is there about resiliency or work that's going on about the impact of those extreme weather events?
Yeah, so there is very much interest around the extreme weather events. There's various efforts. For instance, the Urban Stormwater Work Group, they have a project right now that they're assessing intensity, duration, frequency curves, which are important to different stormwater management practices. So there's a huge concern around our current infrastructure and the current way we set up these stormwater management practices, that they're going to fail under these extreme precipitation events. And they have failed actually with some of these extreme precipitation events where we get failure and then sewage overflow. And so they're very much looking at, well, how we have to modify, or like it's more of an engineering question, like modify this to address these extreme precipitation events. So that's an example of a lot of effort that's going into right now is trying to understand that from a stormwater standpoint. But I'm trying to think of, there's some other examples with the local advisory committee. They represent their local government agencies who participate in the partnership effort. They're very much interested in sort of these precipitation events from a flooding standpoint. And so they're actually meeting this September, and they're going to try to come up with some strategies or plans from a policy perspective that like build resilience to these flooding issues from these extreme precipitation events. So there's different efforts within the partnership that they're trying to look at these extreme weather events.
And Dave, I'll chime in here again, and this also connects to the citizen science effort. There's a group out of the Science Museum of Virginia that's looking at urban heat impacts as an extreme weather event, and they've done some really interesting mapping of DC, Baltimore, Richmond, and other places around the country, looking at temperature differentials to then like trigger policy decisions and support for communities that are more exposed to those high heat events than others. And it's a pretty cool study. It has a lot of complex social ecological components to it that make it I think a really important thing to look into. And I can drop that link in the chat, or you can contact me and I
I just got it in there.
Awesome, thank you, Krista.
All right, this is Rebecca. Was that the study where people were asked that had cars and they put temperature sensors on the cars last year or the year before? Okay.
Yep.
All right.
Exactly.
I just want to. Okay.